Hello. All right, let's get ready to code. Starting with problem 146. Oh, interesting. This might be the first problem where you have to implement more than a function. 146, LRU cache medium. Design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU cache class. LRU cache int capacity initializes the LRU cache with a positive size capacity. Int get int key. Return the value of the key if the key exists, otherwise return -1. Void put int key int value. Update the value of the key if key exists, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The functions get and put must each run in O1 average time complexity. Okay. So I'm thinking something. Okay, so the first thought is to just store a dictionary. The problem is that's going to be hard to find the old entries, but I have an idea for how to do that also. But let's start with here. We'll start with self dot what we can call it data is a dictionary. We need a certain capacity, so self dot capacity equals capacity. Just need to remember that. Anytime you get, you just return self.data of key. And anytime you put self.data or self.data of key equals value. I am not taking capacity into account right now, and I am not evicting the oldest entries. So if we wanted to take capacity into account, then anytime you put, you would say if len of, I guess, you'd have to know if you're adding or updating. So if key in self.data, then you're good. You no matter what, you could just update the value. Otherwise, you have to know if your capacity can handle adding this key. So if len of self.data is greater than capacity, and I'm not sure what the boundary is. If the number exceeds capacity, so if the length, it won't be greater yet. So we'll start by greater or equal, then evict, else and no matter what, we're doing this at the end. So let's just do this at the end. And change this to be if key not in data and the length is too big, then we evict. Okay. So now we have to remember which one is the oldest element. So here's where we can store, obviously there's a few ways to do this. One of them is instead of storing the actual key in here, we could store a data structure that holds the key and the timestamp. And then we'd have to search for the oldest timestamp when we're evicting. That's going to be slow. So instead, I'm just going to store a queue from collections, import deque. This is the Python way of defining queues. Self.queue equals deque. I don't know why it's called deque. I've always been curious about that. So we've got a queue that starts empty. Every time we add something. Oh, actually, when we update, does that update the recently used, its timestamp? Does that update its timestamp? What counts as used? That's important. Does getting something count as using it? Might have to read this Wikipedia article. Requires age bits. I don't want to know. I'm afraid that the article is going to tell me how to implement it. Do the examples tell me what, can I learn from the examples what counts as used? So we put 1, we put 2, we get 1. Least recently used was 2. Okay, so getting counts as using. Does putting also count as using? Then we put 3, least recently used key was 2. Get 2, put 4. Oh, we also have to return -1 if not found. If key in self.data return this, otherwise return -1. And we can say that data is a dict from int to int. Capacity is an int. I don't know how to type Q, so I'm not going to. All right, I'm going to say that get and put both count as using for purposes of least recently used. So does this idea still work? You have a queue. We have to be able to quickly find things in the queue in order to evict, or in order to update them. Evicting always happens from the end of the queue. So if we never had to update things, if we never had to update their timestamps, then we could just do a queue. But because we have to update their timestamps, that means we have to quickly find where they live in the queue. It means we need an interesting kind of data structure. We need like, I'm thinking like, can I do this in Leetcode? From data classes, import data class at data class key. Not key, we'll call it value. A value is a thing that has an int, which is the value of it. Int, how do I say it? Value int. It has a timestamp. Call that an int. We don't need the actual time, we just need the order. So I'll just call it order instead of timestamp. Then we need one data structure that quickly goes from, so I need to quickly retrieve largest order. I need to quickly retrieve by value. And I need, well, that's it actually. So where am I getting tripped up? So I have my queue. How do I jump from, if what I'm gonna do is store a hash map and a queue, how do I jump from value to position in the queue? That's what I'm not sure about. Unless the queue were like a linked list. Because if the queue is a linked list, and I had, and I had a map that maps value to I don't want to call this value because that's a weird name. I don't know what to call it. It's like, let's call it data. If I map value to data, so I have a queue and then I have a hash map into the elements of the queue. But it's not really a queue. The queue is a linked list so that I can remove stuff from the middle and add it to the front. In order to reorder the least recently usedness of it. So a hash map that points into a queue. Okay, so then every piece of data has a value. It has a previous. And it has a next. I can't call it next because that's a built-in keyword. I'm going to call it next anyway. Okay, I think this will work. So data maps from int to data. This is a weird name now. We'll call this element. Do they have a word for it? No, they just have key value. Wait, key value. I was conflating key and value. So I need to be able to jump to an element by key, not by value. Key goes to element. Okay. We don't have Q anymore. All right, so we have data. We have self.root or head, which is an element. Or we can call it tail. Starts as none. Tail is going to be the oldest element in the queue. Yeah. And we have capacity. Okay. So when you get something, if key and self.data, then you return it, but you also update its position. So you have to take it out of the queue, put it back at the front. Put it at the front. So the way you do that is self.data of key. We'll just grab it. We've got it's a two-dimensional, not two-dimensional, two-directional what am I trying to say? It's a there's two directions of pointers between elements. So this is next. This is prev. I'll just call it prev. Which we have to fix. So if we're removing element, that means element.next needs to point to element.previous so that we're skipping over. So elm.next equals elm.prev. Elm.prev needs to point to elm.next. Elm.prev equals elm.next. I can't do it like this because the order is going to be all messed up. So let's just say next equals elm.next, prev equals elm.prev. And then, because if I have to store these as temporary variables or else I'll be overwriting stuff as I go. So next.prev equals prev, next.prev.next equals next. So the next.prev, so this pointer is pointing to this. Then prev.next, so this pointer is pointing to this. now we've got the pointers coming out of element that need to be updated. So I also need some ifs here. So if there is a next, then you can do that. If there is a prev, then you can do that. Okay, then we have to change element. So elm.next equals none, elm.prev equals none. And then we want to add it back to the front of the list. So I guess in addition to tail, we also need front or head. I'll have to go back here and make sure that stuff points to head and tail, that next and prev point to head and tail if they need to. But first, self.head is now equal to element. Elm dot, here's where we have to decide what the order is. I'm gonna say the order starts at head and then next is to the is older. So head's the most recent. Yeah, I guess I already decided that by doing that. Elm.next equals the old head. So old head equals self.head. Elm.next equals old head. I think if I just do this in the other order, I won't have a problem. Self dot yeah. I don't need to remember the old head. So my next is the current head, and now the current head should be me. The new current head should be me. Then the last thing that's missing is, well, there's a few things missing. There's no way this is the simplest way to do this also. But I know this works, so I'm powering through. How do I make sure tail is updated? So tail gets updated whenever we evict from the end, or if we're getting from the, if elm happened to be tail, then we have to update it. So if self.tail is elm, then self.tail equals prev, because this was the thing before us. Okay, now how to make sure that I guess I don't need to, I do need to do this because we will have nothing coming before us. I don't need to do this because I'm going to set it myself. Yeah, I'm going to set it already right here. Okay. Next, could I have to be updating heads and tails when removing element? No, I already figured that out. Okay. So possibly this is how you get. Don't return elm, return elm.value. How do you put? So if we need to evict something, that just means self.tail. This is going to be the oldest thing. Needs to be equal to self.tail dot prev, because it starts at head and goes next until tail. So yeah, and the new self.tail dot next should point to nothing. Because now there's nothing to the right of it anymore. Let's remember the thing to evict. So to evict equals self.tail. We also have to remove it from the hash map, which means we actually need to store the key here also to grab it from the hash map. No, we already know the key. We don't need the key here. We already know the key. No, we don't. We don't know the key. So we need to remember the key to grab it from the hash map. So, and then obviously this is not what you do. You store, what did I call it? Element. Value equals value. Key equals key. Don't talk to me about next and previous yet. Elm.next equals something, elm.prev equals something. I guess we know that this goes to the front, so self.head equals elm. And we know that elm.next is going to be the old head. I'm just picturing this thing. So we're adding something to the front here, which means the thing that used to be self.head needs to point to us now. So self.head.next equals elm. There's no elm.previous. You're at the front of the list. You don't have a previous. Okay. All right, and then back to where we were here. When we're adding, we're updating the, no, here we're evicting something. So how do I evict it? I need to also remove it from the dictionary. So self dot, what's the dictionary called? Data of toEvict.key, delete that. All right, we wrote too much code for this to be correct. I still have a data somewhere. Oh, these are called element. That's true. You can use strings to this is self-capacity. You can use strings to get around the MyPy type checking when the value is not in scope. Prev and next are required. Can I just say they're not required? Interesting. Can I put it inside the string? I actually don't know how to do this in MyPy. I have to look this up. Data class optional field. Because you could use the word optional. I'll do that, but that's not supposed to be required in Python 3.10 and above. So I don't know if this is because of a Python version difference or if it's because when it's a string. Oh, I have to actually say equals none to get data class to not make it a required argument. Yes, this is fair. Only if there was a self.head to begin with. So if there was nothing in the list yet, then you don't have to do this part. Also, don't I have self.head. Hold on, self.head.previous should be equal to element, not .next. Self.tail, this is only if there is a tail. If self.tail, then you have to rearrange the links. But there has to be a tail if we are over capacity, actually, I would think. So let's get rid of this again and if when you insert the first element, you also need to set it to tail. So if there was no self.head, then self.tail is also going to be equal to elm. How do you end up with no tail? I think we need some print statements. So print put key value, print get key. put 1, 1, put 2, 2, get 1, put 3, 3, and then that's failing. So we should be trying to evict something. Let's print kind of everything here. Self.data, self.head, self.tail. It's hard to tell what's what. So let's put self.head in between here and self.tail here. So this is data. You've got 1 and 2. That's what we expect. Then self.head. Self.head is 1. Its next is 2. That's wrong, actually, already. It's head should always be the most recently added element. So I would expect head to be 2 and tail to be 1. Here we have it the other way around. So when we put we create an element. Oh, I guess I'm not handling the cases properly here either. This is, this means you have to evict. You might have to update it even if you're not, if it's, what am I trying to say? If, let's return here. Let's not return there. If key in self.data, then we have to update the order. Like the used order. Otherwise, we put it at the front. So update the used order. Is the same thing that we're doing up here. So let's pull that out into its own method. Def update used self key int returns none. And I think you do all of this. Oh, you know what? I don't need, I can just call get. Self.get key. We're still in the wrong order though, probably. So let's try to figure out how that's happening. We're just doing put, and then we're doing a get, and then we end up in the wrong order. So put 1. Can I print self.head every time we put or get? Let's print self.head. Okay, and this is the value, the value of self.head before the put happens. So it starts at empty, and then it's 1 with no previous and no next. And then after we've put the 2 in there, head is 2, next is 1. Oh, I think that it was working actually. And then when we get 1, it should be in the other order. So then it should be 1, 2. 1, 2. Okay, so put and get both seem to be working, except that tail is not what we expect it to be. So let's try to print tail. So it starts as none, none, and then they're both 1 when we insert the 1. And then when we get the 1, or yeah, before we get the 1, we expect the order to be 1, 2. So head should be 1, tail should be 2. And that's what we see. Then when we put 3, 3, we have just finished getting 1, so the order should be the other way around. Head should be 1, tail should be 2. And that is what we see. Oh, but this is not set properly. Head correctly points its next to 2. Tail does not correctly point its previous to 1. So that means get is not correctly setting the value of tail. So tail is getting... If tail is the element that we have removed, then tail becomes prev, and that's what we expect. Our problem is that we're not setting prev. Wait, we're not setting... We're not setting element.prev. Or something. What is this supposed to be? Like, we know it should be element 1, but if you're thinking of removing an element from a list, the head is on this side, the tail is on this side. So my next is not getting its prev set up properly. Elm.next next.prev equals prev. Why doesn't that set this? So we get 1. 1 was the tail. So it has no next, which means tail, which means element was tail. So we're checking that here. If element equals tail, then self.tail equals prev. And that's working right. The problem is this prev is not pointing to the element that was just inserted at the head. Self.head equals elm. I'm never setting elm.next. Yes, I am. I'm setting it to self.head, which is right. I'm never setting elm.prev. I shouldn't have to set elm.prev. Oh, this is so confusing. The tail's on this side. I'm removing the element. There's going to be a new tail. So prev is becoming the tail. I shouldn't have to set prev.prev just because I'm removing element, but I should have to set something.prev when I add something to the front. Yeah, I'm not setting the old head's prev to be me. And I do need to do that. So self.head.prev equals elm. There we go. That was the hardest. It's always hard to figure out these cases like this. Okay. So does this work? Let's submit. The linked list stuff is always just so finicky. All right, let's bring our print statements back. And see where we're going wrong. So we put 2, 1. We started with no head, no tail. Then we get to head and tail are pointing to the same thing, and they should still be pointing to the same thing. Oh. After getting, we didn't correctly set tail. Okay, so the use case is head and tail are the same thing, and now we're getting. So you get elm. Next and prev are both none. So you skip over this. Elm.prev is none, which it already was. Elm.next. I'm going to be setting it to myself, which I shouldn't do. I think here I should say if elm dot if elm dot, or if elm is not the head. So if I was already the head, you don't actually have to do anything if you're already the head. You don't have to do any of this stuff. So if self.head equals elm, Just return the LML value. Don't need to reorder if it's already the head. Okay, so that fixed that bug, but that wasn't the only bug. So when you put 2, you started with nothing, nothing. Then when you get 3, or get 2, you don't end up reordering. Then when you put 3, we have not reordered. And then what's the error? Here we're trying to put 3. We are over capacity. So we must evict. I don't think it's highlighting the right line in the editor here. I think the error is on this line. None type has no attribute prev. The tail is somehow none. It shouldn't be none. We can see right here that it's not none. Self.tail equals self.tail.prev. Self.tail cannot be none here. We've just printed it and it wasn't none. I don't understand. Oh, I mean, I understand how this could fail, because self.tail could be none at this point. So here we should add a if self.tail. But that's not the line it was highlighting. Oh, it may have just gotten confused in the line numbering somehow. Submit that. This is a different test case. So let's use this test case, put our print statements back in, and try to understand what's going on. So we get 6, which doesn't do anything. We get 8, which doesn't do anything. We put 12, which gets our head and our tail to 12. We get 2, which shouldn't do anything. We still have 12, 12. We put 15. Which puts our head to 15, next to 12, and it put our tail to nothing. Okay, so putting a new element to the front ended up erasing our tail. Put a new element to the front, so elm. Is the new element. I also have just realized that I don't think I'm doing puts properly because I'm not updating values. Like I'm updating it to a new element. Oh, I guess I am just like destroying the old element. No, I'm not. I'm updating it back to the front. But then I'm adding it again to the front. So I'm not updating properly. At this point, what I should be doing is elm is this, elm.value equals value, return. That's not the bug we were trying to fix, but that would have come up because we were not actually updating the value. We were reordering it and then adding something new in front. Okay, and now if it's a new thing, our problem is what again? That we ended up, when we put 15, which was a new element, we ended with no tail. So in the process of evicting, we lost our tail. So this is evicting. Self.tail equals self.tail.prev. That is what you want to do. Then if you have something, if self.tail's not none, then you have to make sure that it points, that it knows that it's the end of the list, so it has no next. If it was none, then you have to just self.tail, self.head and self.tail need to both be pointing to the only element. Or is that right? Why would self.tail be none? If there was nothing before, but why would there be nothing before? So in this case, we have 12 and 12 as the head and the tail. Then when we try to put 5, we ended with no tail. So key not in self.data, and we are over capacity. We are over capacity, right? Yeah, the capacity is 1. So we try to put 5. To evict is tail. The new tail is going to be none. The new tail is going to be none. I guess I don't know why I'm failing at this point here. No, I guess I'm not failing yet. I'm going to be failing. when I try inserting 5, but right now I'm trying to insert 15. Okay, so the new tail is none. We only have one element and we're evicting it. So self.tail is now none. If self.tail, so that's not going to happen. Now we're deleting self.data. The thing we need is if self.head equals to evict, then we also need to remove self.head. Okay. Submit this. Okay, what is this new and interesting way to fail? Get right now is returning the value, not the element. That's true. So what I want to do here is self.head.value equals value, because I know it just moved to the front of the list when I touched it here. Let's submit that. Let's remove our print statements. Okay. Yeah, we're in the pack here. I think this is overly complicated, but I also think it's optimal in terms of runtime and space. We're using a constant amount of overhead, and everything is O of 1, even though there's a lot of finicky links to update. So yeah, I'm happy with that. How did other people do it? Is there a simple way to do this? Double linked list. Look at that. Double linked list. Yeah, we actually did it the best way. Okay, look at us. Next problem. Number 147. Insertion sort list. Medium. Given the head of a singly linked list, sort the list using insertion sort and return the sorted list's head. The steps of the insertion sort algorithm. 1. Insertion sort iterates, consuming one input element each repetition and growing a sorted output list. 2. At each iteration, insertion sort removes one element from the input data, finds the location it belongs within the sorted list, and inserts it there. 3. It repeats until no input elements remain. The following is a graphical example of the insertion sort algorithm. The partially sorted list black initially contains only the first element in the list. One element, red, is removed from the input data and inserted in place into the sorted list with each iteration. Okay, so you iteratively consume from the end, and then you iterate backwards to find where to put something, and then you push everything forward. Okay, so it's O of n for each insertion. And we've got a singly linked list. Okay, so we have no choice about our runtime. Our runtime must be O of n squared because it's telling us use insertion sort. Which is a weird kind of Leetcode problem where it tells you exactly what you have to do and you're not allowed to think of a better algorithm. All right, let's do this. So let's, because I don't know what to call stuff, we'll have a variable called red box, which starts at head. We're gonna have two, it's a singly linked list. So we're not actually going to iterate backwards. Does it say that you have to? Consuming one input element each repetition and growing a sorted output list. At each iteration, insertion sort. Oh, actually, we can do it. We can do it. So red head, or not red, black head, black tail. So we can just grow. No. We can't go backward. Does it say that we have to go backwards? Because if I just insert from the front each time, that'll be simple. If I have to go backwards, then I have to like store the black list in reverse order and flip it at the end so that I can iterate from the right direction. Finds its location and inserts it there. It just says find its location. So I'm going to insert it from the front. Red list. Or we'll just call it unsorted and sorted. And this one can be a dummy. It can start on a dummy node. And then at the end, sorted is not a good name actually because that's a built-in name. Let's call it underscore sorted. Unsorted and underscore sorted. Return underscore sorted dot next. And then in the middle here, we do our insertion sort. So while head, so this is iterating the outer pointer, the one that grabs an element, and so head is going to be like our red box. And then we have the inner pointer, which is while head dot next. No. While head dot val is greater than sorted. Here, we'll just call this we don't need a variable for this, and this we can call sorted head. And we need a sorted cur, which we can define over here. No, which we have to, well, yes, which we can define over here. Sorted cur equals sorted head dot starts at sorted head. Okay. The inner loop iterates by incrementing sorted cur dot sorted equals sorted cur dot next. The outer loop iterates by incrementing head equals head dot next. So this is while sorted cur, and my value still is to the right of sorted cur. So at this point, we found where in the sorted list we want to do our insertion. So head.next equals none. Here we're doing our insertion. Do the insertion. Head.next equals none. No. Then we would lose. Okay, I guess we do need an unsorted head to start at head. So unsorted head is going to start at head.next. Head.next can be none. The place where we are, so cur, we have just found that sorted cur needs to come. No, we just found that head needs to come after sorted cur. This should be less than. While I'm less, I keep iterating. Once I'm not less anymore, then I'm more, which means I need to come after sorted cur. So sorted cur dot next equals head. Which means my sorted head can be equal to head. Now head is the new sorted head. Okay. I feel like this isn't quite right, but I think I need to see an example now. Underscore sorted is not defined. Yeah, what did I even mean to say here? I meant sorted cur dot val. And here I want to return sorted head. Whoa, so this is not right. Sorted head. Sorted head doesn't point to head. What is sorted head? Sorted head is the first element. Okay. Let's think about how to do the insertion. Unsorted head so unsorted is the stuff starting at the red box equals head.next. Head is iterating over the unsorted stuff. So head is the red box, and we're gonna put that somewhere. So start. I don't want to say head.next is none. I want to say head.next is where it's supposed is like sorted cur. Dot next. It comes after. It basically, yeah, sorted cur dot next points to head. So sorted cur comes before head, and then after head is whatever was after sorted cur. So this seems more right now. I'm still getting confused, and I still feel like I have too many variables. And I've never set sorted head. I think if this is the first time I did it, then if sorted head.next, if not sorted head.next, sorted head.next equals head. So we start it at the first red box. None type has no attribute next. Which one of these is that? I can't tell if it's complaining about head or sorted cur. It can't be head because we're in a while head. So sorted cur. Another thing is I want val to be equal to negative infinity on this because I want it to always come at the beginning of the list. So I never want this to be true for the dummy head. Okay. I returned 4. We expected 1, 2, 3, 4. I'm returning sorted head. So if I print sorted head at each step, am I just never updating it? I'm not iterating. I'm not even iterating over the list. So I am doing head equals head.next, which doesn't make sense anymore because I overwrote that. So let's remember it. Temp equals head.next. Three, 1, 2, 4. Zero, 4, 3, 5, -1. It's like a random order. It does have every element though, but I think we need to reread our code and think about what we've done. In other words, think about where exactly things are getting are being inserted into the list. So the sorted head, so this is the black box, starts at a dummy node. The unsorted head starts at the start of the list. Do we even use unsorted head? Yes, we do. Actually, and we don't need this temp because this is already what unsorted head is. But yeah, we don't need to remember this outside. We only need the sorted head. Okay, so we start. Head is supposed to be the thing we're iterating over, and that seems to be working because we end up getting everything. The sorted current value starts at sorted head. While we have a sorted current value. Why don't we just start this at next and then we don't need the infinity? Well, it's because no, yeah. No. Hold on. We actually do need to insert stuff to the beginning of sorted head sometimes. So I think I'm starting to see where the problem is. While sorted cur, so this will be true on the dummy node. I don't want to do .next because that's going to start as none, and then we'll never do this. While sorted cur and a thing that will never be true on the first iteration, increment sorted cur. So we're going to start with sorted cur as pointing to sorted head, which is the dummy node. Do the insertion. So that means the next unsorted node, we want to remember what that's going to be so that we can iterate. Head.next, so head is my red box. That goes to wherever sorted cur was going to go. So right now we're inserting after sorted cur, because we're always going to be the first value greater or equal to head, or sorted cur is going to be the first value greater or equal to head. So sorted cur.next is head. And wait, is this right? So head.next yeah. Head, like if I have a little picture, we've got sorted cur points to like sorted cur.next. And we're going to be inserting ourselves here. So sorted cur.next equals head. And head.next. Wait, you have to do this in the right order. Head.next is sorted cur.next. And then sorted cur.next is head. So that's the right order. All right, the problem is we just went through this and we didn't change anything. But that's not going to work because we have the wrong answer here. So 4213, our sorted head has nothing. Head is going to be 4. So is 4 less than negative infinity? No, so this will not execute. Which means sorted cur is going to be pointing to the dummy node. Then we're going to do the insertion into, if I'm printing, shouldn't I be able to see? Yeah, so it starts at only the dummy node, and then the dummy node next is 4. That's what we expect. And then dummy node, next is 2, next is 4. That's also correct. And then we do 1, 2, 4. That's also correct. And then we ended up inserting 3 in the wrong place. Is it the same here where we... No, here we made more than one mistake. Well, let's start with this one. How did we end up inserting 3 in the wrong place? So 3... This is what sorted head looks like. So now head is going to be 3. Let's confirm that. So head.val, comma sorted head. Okay, so we insert 4, we insert 2, we insert 1, and then at the time that we're inserting 3, we have 1, 2, 4. So while sorted cur, which starts at sorted head, and my value is less than sorted cur.val. So here we should have stopped when we got sorted cur to be this, because at this point, head.val, no, head.val would still be smaller than 4. So we should have gone all the way to sorted cur equals none. Is that right? Let's print sorted cur dot val. It's negative infinity each time. That doesn't make any sense. How could it be negative infinity each time? Shouldn't this be executing? Head.val less than... Oh. Sorted cur.val starts at negative infinity, so this will never happen. I think I actually want it to be positive infinity so that we always try to insert. No. Hold on. What do I want here? I always want to go past sorted head. No, I don't. I don't want to go past. Okay, here's the confusing part. This is not a good way to do this, but I just want to make sure I always have a node at the front and the back. sorted head.next equals sorted tail. And then at the end here, we want to remove sorted tail. Which is annoying to do because I have to iterate over the list again. Okay, let's not do that. We just have to think of the edge case instead. So we have this dummy node with negative infinity. While I guess I want while we're greater than the elements, we keep going forward to see where we want to go. So I kind of had it backwards. I think this will fail now because something's pointing to none. Oh, well, that is another reason why it would fail. Okay, so now sorted cur can be none. And it's because we're going past the end of the list. So I think we also need sorted prev to be equal to sorted head, sorted cur to be sorted head.next. While sorted cur and you're greater, then you increment both. So sorted cur goes to 1 next, sorted prev becomes sorted cur. And then you do the insertion on the previous element, not the current one. Okay. We'll submit that. We can definitely do better than this. Like not asymptotically, but our code is really goofy. Like for example, we don't need to remember the previous and the current. We could just say the current is the one before the one that we're comparing. It's interesting, this bimodal distribution here. What are these people doing? Oh, they're probably not doing insertion sorting, actually, because the problem says do insertion sorting, and that's not a fast way to sort things. So those are probably cheaters. So I can just not have a sorted cur. Call this prev instead of sorted prev. While we have a next and the value this way we don't have to keep track of those 2 pointers. We just have 1 pointer, and it's the pointer to the previous thing. Yeah, it doesn't change our runtime. Okay. That's good enough. On to the next one. Number 148, sort list. Given the head of a linked list, return the list after sorting it in ascending order. Follow-up, can you sort the list in n log n time and O1 memory, as in constant space? Yeah. Constant space. Yeah. So we can use any sorting algorithm that has an in-place variant. So I think merge sort is probably the simplest one. In merge sort, oh wait, actually, splitting the list in half is not. Yeah, you can split the list in half because you can use ON on each iteration. So in merge sort, you split the list in half. You recursively sort each half, and then you merge the results. So we can do this on a linked list. Splitting the list in half means you iterate over the whole list. Like, you can do this a little bit faster if we remembered the length of the list, but it would only be half the speed. So the split the list in half is you iterate over the whole list to find out how long it was. Actually, another way to do it is you have a walker and a runner. So you iterate over the list. Yeah, we can do it that way. You have 2 pointers, and one of them jumps by 2 on each step, and one of them jumps by 1 on each step. And so when the fast pointer gets to the end of the list, the slow pointer is at the halfway point. It doesn't need to be exactly halfway in order to be n log n. It just needs to be approximately halfway. You need to be having the space each time. But if you have +2, that still counts as having asymptotically. Then we call ourselves on the recursive thing, and then we merge the results. Okay, so base case. If not head.next, return head. So if you're a 1 element list, then you return yourself. Yeah. Split the list in half. So walker equals I just want to make sure that that when there's exactly 2 elements, that it returns the correct halfway point, because that's what's going to make my base case work. So let me just write it, and then we'll fix it. So walker and runner both start at the head. Then while walker equals walker.next, runner equals runner.next.next. It's not while walker, runner is the one who's going to run out. And here we need to break if the runner steps too far. Or I guess I could just say while runner end runner.next. Are they also, why do they say optional? I guess I also have to, if not head or not head.next to handle the case when they don't give me a head. Okay, the problem with what I have, there's two problems. There's one problem with what I have here. And that is walker and runner can end up on the same node. Right, walker. You know what? This is too fancy for me. Let's just do it the stupid way. N equals 0 while cur equals head. While cur equals cur.next. N plus equals 1. If no, I don't like this. Let's go back to the walker and runner. It's just that we need a previous also. Prev equals walker. Then at the end of this, I can say prev.next equals none. And that splits the lists in half, where walker is the head of my second list. So head 1, head 2 equals head and walker. I just need to sort out the edge cases here. We know that head has a next, otherwise we would have been in the base case. So there's at least two things. That means runner and runner.next. This will execute at least once, which means walker and runner can't be the same. And it means previous and walker can't be the same. Good. That's all the properties we needed. Okay, so now the lists are split in half. Now we recurse on each half. So self.sort list. Here, we'll just say head 1 equals sort list head. Head 2 equals self.sort list walker. And now we get to merge. So while head 1, do I know whether head 1 or I should know which list is longer when they're not equal length. because of the way that I'm walking and running. So if, let's say I have 3 elements, prev, after the first iteration, prev will be head, walker will be the second element, and runner will be the third element. And then we will not iterate again. So prev is head. Okay, so the second list will have a longer length. Okay. Merge, then if there was one left over, add it, and then return head. So let's make head into a dummy node, list node. Is it just called list node? Yeah. So our new head is a dummy node. While there's stuff in head 1, it's if head1 dot val is less than head2 dot val, you head tail equals head. Tail dot next equals head1, and then head1 dot next equals head2, and then tail equals head2. Else, so if it's the other way around, tail dot next equals head2, head2 dot next equals head1, tail equals head1. So that's just how you merge them, always putting the correct, the smaller element first. Then we might have a leftover. So at the end of this, oh wait, while we're iterating, we also need to do head1 equals head1 dot next, and head2 equals head2 dot next. Then at the end, if head2, so if there was a leftover, tail dot next equals head2, then return head. None type. How do we end up with a none type? Let's print head at the beginning of all of these. Let's print head1 and head2, I guess. Print head1, head2. And the string head1, head2 also, so I can find it in my output. So we're trying to merge the number 1 and the number 3. Oh. I just need to remember these temporary variables because I'm messing up the list before I go through. So temp1, temp2 equals head1 dot next, head2 dot next, head1, head2 equals temp1, temp2. Interesting, I ended up with 0. Oh, because my head is a dummy in more ways than one. So I do want to skip over the dummy here. What's the error now? None type object has no attribute next. So I thought I knew that head2 must be greater or equal to head1, which means that this shouldn't happen. This is telling me that head1 is 3 elements long and head2 is 1 element long. I mean, that's fine if I just got it backwards. I don't know how I would have gotten it backwards, though. I thought I checked. And now it says it's the other way. Okay, I don't think I got it backwards. So how are head1 and head2 not what I expect? -1 and 5, and we've got 4 on the other side. I mean, that doesn't seem to make sense, because where did 3 go? How can we be merging -1 and 5 and 4? I think we might have lost something in the split. Oh, okay, so here's one thing. At the end, what I need to do is tail.next equals none. Otherwise, my list is weird. Like I could have a cycle. So I'm ending up with 3 on one side and none on the other side. That's definitely not possible. What if I print my overall head right before and remove that print up there? My overall, oh, I can't do that because I've changed it already at this point. So something got lost, but I'm not sure where. So if you have no head, you return none. But we're not supposed to call sorted list on a none. If you have no next, then you return head. So you just return your self empty single node, not empty, but single node. When we run across to split the list in half, we keep track of previous. We know this has to execute at least once. Otherwise, we would have been in the base case above. If this executes once, then we know prev, walker, and runner must have different values. We know walker is not none. If walker is none, raise exception. Just double check that. I'm pretty sure we know walker is not none. Okay. I guess I'm interested in printing at this point head and walker, because these are supposed to be my two separate lists. So -1, this is a little hard to read. Let's print head, new line, head. And same for walker. I did forget a comma. So we've got -1, 5 for the left side, and 3 and 4 for the right side. So the input here, -1, 5, 3, and 4. Where did our 0 go? -1, 5. Oh, the 0 is on the right side. 0 is on the right side. So right side is also longer than left side, which is what I thought. But after we recursively sort them, now we've lost most of the values. So at this point we have them, and then we've lost them after this. So how did that happen? That means this must not be working properly. Head is a dummy node. Tail starts at head. While we have stuff from recursively sorting the head 1 and head 2, if head 1 is less than head 2, you add that to tail. So tail.next is head 1. Head 1.next is head 2. And our new tail is head 2. Oh, this isn't even... Okay, this isn't how you do a merge sort. You don't just add them both. You have to do them in the right order. So, yeah, okay. While head 1 or head 2, if head 1.val is less than head 2.val, Then you add head 1. So tail.next equals head 1. Head 1 equals head 1 dot next. Else tail dot next equals head 2. Head 2 equals head 2 dot next. So you add them all, and then when there's leftovers, if there were leftovers, or how about just add the leftovers? So if head 1, then tail.next equals head 1. So this adds all the rest of the leftovers because it's a linked list. If head 2, tail.next equals head 2, we don't even need to keep track of tail anymore. We do actually. We have to set it to none at the end. So while tail equals tail.next, and then set it to none. Okay, that's true. What I mean here is and. So while there's still stuff to compare in both lists, then you add whichever one's appropriate. Otherwise, also I need to set the new tail. Tail equals head 1. Tail equals head 2. How does tail end up empty here? Oh, because of the order I'm doing this in. That's true. I want the one before. So while tail.next. So this is this tail will be the will be the one before the end, and that works. So let's remove our print statements and submit. Okay. So that's merge sort on a linked list. I mean, this is there's ways to improve merge sorting, like having a bigger base case, because the recursive stuff is how do I say? It's like the recursive stuff is more expensive than doing like simple operations usually. The other thing I just realized is I don't think I technically solved the problem with O1 memory. I actually solved it with log of n memory because we have to store the recursive stack as we go down. Yeah. To do it in O1 memory, I would have had to do something like a quick sort. I actually don't, off the top of my head, know how to do an in-place sorting algorithm with O1 So why don't we take a look at the solutions? All right, so they've got merge sort, which I say is not actually O1 space. Yep, log n recursions. It is not constant space complexity. Okay, so have you got a recurrence and divide and conquer, but it consumes program stack to store the recursive stack frame. Recursion use up to bottom strategy. Why not try the opposite way, bottom to up? Luckily it works, only consumes O1 space. That's a lot of code though. Okay, and people saying the non-recursive thing is kind of hard to do. Bottom-up merge sort. I guess I can think of how you would want to do this, right? You have your whole list of elements. Bottom-up merge sorting would mean you're keeping, basically iterate over the list log of n times, and each on your first try you're comparing these things, on your and these things and these things and these things. On your next try you're comparing these things and these things and these things. On your next try you're comparing these things and these things. So you don't need the whole recursive stack because you know how many elements you're jumping over at each step. That's my intuition of how you would do a bottom-up merge sort. This is bit shifting left by 1, which means multiplying by 2, which is what I was saying. Like you increase the window of what you're merging each time. Okay, interesting. So we could have done that. I didn't think of it until after we submitted, and now we've already looked at solutions. So let's move on to the next one. We got a hard one. Number 149, max points on a line. Hard. Given an array of points where points of I equals xi, yi represents a point on the xy plane, return the maximum number of points that lie on the same straight line. Okay. Okay. Okay, so some immediate thoughts. Any 2 points form a line, and you can make the equation of a line. And then you can check if a third point is on that same line using the formula for the equation of a line. You set the value of x for 1, and then you see if the value of y ends up being what it needs to be. So you can easily generate a line from 2 points, and you can easily check if a point lies on a line. Those are both O1. Let me write this down. Let me start writing stuff down. O1, check, generate a line from 2 points. O1, check if a point is on a line. So here's a n cubed solution, which is not good. We can do better than this. For each pair of points, count how many other points are on the line. Or on their line. So it's n cubed because you iterate over every pair, so that's already n squared, and then for each pair you check every other point, so that's another n. So how can we do better? It's hard to think of how to do better. It's pretty hard to think of how to do better. Because every pair of points does generate a line. Like in this image, how would we know that this line doesn't have more points on it? I don't immediately see how you could know that other than to generate the line and to check if the points are on there. I'm trying to think, like, when I look at this image, I immediately can tell that their longest line is here, even if it weren't dotted. And what am I doing? So I'm basically, when a dot is nowhere near the line, I don't have to consider it. And when it's near the line, I have to use the formula to check if it's on the line. I'm wondering if this idea of nowhere near the line can actually form a heuristic. What does it mean for something to not be near the line? I don't know. I don't know other than like you do the check and you see that it's not right. So far n cubed is the best I can think of. What kind of format are they giving us these points in? So negative 1,000 to positive 1,000. Can they have decimals? No, they're integers. They're integers. So something else I'm thinking is like, how do I say this? I'm trying to think of like, let me write down the equation of a line. So you've got y equals m times x plus b. And then you have x1, y1, and x2, y2. If you plug those into this, you end up with y1 equals mx1 plus b, y2 equals m times x2 plus b. We can solve for m and b. In theory, but my math are not so great. So let me think about it as vectors for a second instead. So if you have x1, y1 minus x2, y2, that gives you this vector, x1 minus x2, y1 minus y2. And we know that another point is on the line if it's like in the direction of this vector or of the negation of this vector. So if I'm having so much trouble converting my visual understanding into something I can write down and say out loud as math. So you define a line with 2 points. Another point is on the line if it's like a scaled version of the vector. I think this is going to lead us somewhere. I just need a second to convert math into words. So if the ratio of like x over y is the same, how do I check that a point is on a line? You do the formula's right here. I'm just too stupid at math to solve it. All right, I can do this. I can do this. Put b on one side. So minus on that side. Put this minus on that side. Now you've got the formula for b. Put them both on the same side. So to eliminate b. Now we want to isolate M. No, we're trying to find, well, okay, yeah. Now we want to isolate M. So put the two M's on the same side. This becomes a plus. It becomes a plus. Subtract this on this side. Let's pull M out. So this is M times negative x2 plus x1. In other words, x1 minus x2. And then you divide this on the left side. Okay, so M is equal to this. So the slope of the line is that. B is what? I guess we need to do that again, but now we plug this into M in the formulas up there and solve for B. So this was M. Let's leave it as M for a second. Let's put B on the left side. So subtract this. Subtract this. No, we want to put M on the same side. No, we already did. Yeah, let's put M. Let's put M on one side and then replace it. So minus B. We're watching me do basic arithmetic, and I know it's painful. So minus B on both sides. Divide this side by x1. Divide this side by x2. Set these equal to each other. They're both equal to M. Now we want to solve for B, so put x2 on this side as a multiplication. Put x1 on this side as a multiplication. Let's factor it out. So y1 times x2 minus b times x2, y2 times x1 minus b times x1. Put the b's on the same side, so this becomes plus. I'll put it in front here. Wait. You take this out and it becomes plus on this side, so like that. Let's put this on the other side, so this becomes minus that. We'll take the b out of the factor, and then we'll divide this side by that. Okay. So is this what we figured out? This is how you figure out the equation of a line. Then you have y equals mx plus b. So if you have an x and a y, you plug in the x here, you see if the y agrees with your y, and that's how you know if it's on the line. All right, all of that did not give me an idea that's better than n cubed. It's like, oh, hold on. No, you'd still have to try every pair. So the thing I'm thinking is, imagine you have a horizontal line that you're trying, or a vertical line, and then you rotate the line around in a circle. And whenever it intersects with stuff, you check how much stuff it intersects with. But that doesn't work because you need the line to start somewhere, like at some x. So it's not like you can just rotate one line in a circle and be done. Because if you did that, like, well, yeah, I'm not seeing how you do better than n cubed. I think we try the n cubed and see how it goes. It's probably going to be too slow, but maybe we'll learn something from doing that. So for P1 in points, for P2 in points, we don't have to try them both. So we can say I P1 in enumerate. Like we don't have to try both directions. So this cuts our search space in half. In points starting at I. Generate our equations. So m equals this stuff. Oops. x1, x2 equals p1. No, x1, y1, x2, y2 equals p2. M and b are these things. Then for all the rest of the points, for P3 in points, if P3, so the formula is y equals mx plus b. So y equals m times x 3y3 equals p3. Y equals m times x3 plus b. If y equals y3, count plus equals 1. And we're returning the max, yeah. So best equals 0. Best equals max of best and count, which we only have to do on the outside of the loop. Return best. So does it even give the right answer? I'm worried about like divisions by 0. Yeah, there it is. What do you do if the slope is infinite? How do you check that points are collinear? Can you print me an example? One with itself. Wait, why did I end up looking at that? We're supposed to start after I. Do I need to do a +1 here? Okay, this time it's 1, 1 and 1, 4. So x is 0, or x1 minus x2 is 0. If I just picture 1, 1 and 1, 4, shouldn't the slope be 0? Did I screw up my x and my y somehow? This is the x-axis. I guess it doesn't actually matter. It's just that we should think about these two. So if x1 and x2 are the same, then how do I check if points are on the line? Any point with the same x will be on the line. So let me make a little class for a line here with an init that has an x and a y. X1, Y1, X2, Y2. We'll add a collinear for an x3, y3. It says if x equals, or if self.x1 equals self.x2, return self.x1 equals equals x3. Otherwise, do the line stuff. So return y equals mx plus b, and this y return return if y3 is equal to m times x3 plus b, then you're on the line. So here you've got x3, y3. Line equals line of x1, y1, x2, y2. If line dot collinear x3, y3, or count plus equals line dot collinear. Init, spelled that wrong. All right, we're getting the right answer. Let's just see what happens. I think this will be too slow, and there's some clever way to speed it up, but we'll see. Oh, I'm getting the wrong answer. Okay, come on. I think we just have to handle that case separately. So, if len of points equals 1, return 1. Oh, these need to be self. If x1 is not equal to x2, self.m equals this. We don't actually need to remember these. Self.vertical equals x1 equals x2. If not self.vertical, then y is that and b is this. If self.vertical, I guess we do need to remember x. Otherwise, here's the line formula, self.m, self.b. Okay. So my first question is, am I trying every P1 and P2? Yes. Yes, I am. Then am I trying every P3? Like, can I just print P1, P2, P3, and whether it thinks it's collinear? Well, this should say true. I don't know why this says false. You're clearly collinear with a point that is part of your definition. So my formula must be wrong. So what are we saying? Print self.m, self.b, and this. So 0 and 2 are my m and my b. And then I'm saying 2 is m times x3 plus b. M times x3 will be 0, plus b will be 2. Then I'm saying if 2 equals 2, aren't I? Is it because of the float? Python 2 equals 2. Should be equal. Oh no, wait, equals 1. So I'm doing 1, 1. Well, m shouldn't be 0, actually. M should be 1, because the slope is of these 2 points is just vertical. Or not vertical, is diagonal. So x1 minus x2 is -1. So that's the denominator. y1 minus y2 is -1, so m is just 1, which is what I expect. But then why are we saying that m is 0 here? When it should be 1. How does that make any sense? Okay, how about down here? Give me line.m before you tell me if it's collinear. Oh, I'm just passing this, or this should be y1. I just wrote that wrong. It was just a typo. Okay, that's more like it. So I think this will give the right answer, but I think it is too slow. Wrong answer. Oh, they're gonna make this so hard for me. I wonder if it's because of rounding errors. I'm also thinking that the fact that these are integers is going to be something we can use to speed things up with some kind of modular arithmetic stuff. But this is just going to be really annoying to debug. What if I just said if the absolute value of the difference is less than a really low tolerance? What if it's a pretty high tolerance? Why is this not working anymore? Wasn't this example working before? Was this example not working before? Once I add the tolerance, it stops working? I'm just thinking about the integer-iness of it and how there's some modular arithmetic you should be able to do that will help, because it's like I'm not sure how to formulate this idea yet, but it's something like if there is a divisor, if you want to check if something is collinear, it's like you have this point and you have that point. And then you want to know if you added the x and the y over and over again, would you ever find the new point? If you added x2 to x1 and y2 to y1 over and over again, would you ever find x3 and y3? Which is basically asking if something is a divisor of something. The only problem is you'd have to find the least common multiple first, I think. Because if I'm talking about the point defined by this and this, then by adding this to this a bunch, I'm never going to find these guys. I need to first find the least common multiple. Let me write down what I'm trying to say. I don't know if this is going to be relevant, but it's like you have x1, y1, you have x2, y2, and you want to know if x3, y3, like let's say x1, y1, and x2, y2 are already, you already did the thing that I am having trouble saying, where you turn them into a least common multiple of each other. You want to know if there's a way to do x1 plus some amount of, like, let's say k times x2 to be equal to x3, and the same k to get you the y. Like, can you add p2 to p1 some integer multiple number of times and end up with p3? So instead of trying every k, I think you can do some like modulo thing. Because the trying every k would be like while k while true k equals 0, k plus equals 1, p3 equals x1, y1, or like p equals x1, y1. p plus equals x2, y2. And that'll find you the k. I don't know. I think there's something there, but why doesn't this work again? It works on small numbers, but then there's possibly a rounding error or something on big numbers. The example that fails is too big for me to figure out like where it's failing manually. This is so frustrating because I'm close in both solutions, but I'm just having trouble like articulating the math. This one is annoying because I can't tell which number I'm missing. I guess I could add some more print statements and figure it out, because it's whichever one has 10. So what if I would just print, if you are collinear, print x3, y3. And then how can I tell which one is missing? It's almost like I'd have to do this just to figure out which of these should be here but isn't. Because the thing I haven't written down here yet is if p equals, the p that you're looking for, then you found it. And if you go forever, then you are not collinear. I know there's some way to turn this into some mod formula, but It's also so confusing that the absolute value of the difference, or the difference, so y3 minus this, being less than a small number. I don't know why this isn't working either. Because isn't this the same as saying y3 equals this? Oh, yeah. No, I need to flip the sign because I didn't put parentheses. Oh, okay. Well, that's just going to work then. I just forgot to flip the sign last time I did this. Or it's going to be too slow and we have to figure out the modular thing. No, it works. But it's slow as hell. Okay. N cubed. Not good for two different reasons. Like, this is horrible. And I want to figure out the modulo thing so that I don't have to do floating point comparisons with a tolerance. The other thing is, I don't know that n cubed is the best way to do it. I think actually it's definitely not, because of how slow our answer is. And the modulo thing's not going to make our answer that much faster. All right, so I want to think through the modulo thing because I think that might also give us a better way to check collinearity. Well, okay. No, that's not really going to help. I was going to say... Oh, wait. I think there's a way to get to n cubed, or I'm already at n cubed, n squared, by having a... So the thing I'm thinking is, instead of going through every P3, if we could skip to the collinear ones by having some kind of data structure where you can jump right to the collinear ones. Like, one way to do it, which would not be faster than this, would be to store our points in a set, to generate all of the collinear points, which we can do with this stupid loop, and then to check if each one is in the set. We have a limit on the size of the x and y coordinates. It's 1,000, right? Yeah, it's 1,000. So we would check at most 1,000 or 2,000, because you could go from negative 1,000 to 1,000. We would check at most 2,000 set inclusions. Which would be stupid because we have at most 300 points. So it'd be faster to check the points than to check the set inclusions. But this is the kind of idea that I'm thinking of. It's like, if we could pre-process the points into something okay. Here's an idea. For each point, move it to 0, 0, and move all of the other points, like shift all of the points so that the point you're considering is at 0, 0. So that's part of your, that's going to be O(n) squared already. So for each point, you do n amount of work. Then for each point, which is at 0, 0, you're trying to, you iterate over every other point. So now you're at n squared. And now we want to jump directly to the other points that are collinear to you. This is the same idea as before. It's like, I can iterate over the points that are collinear to me. And then just check if they're in the set. But the number of points that I might have to check is really big. Is there a way that I can just store some property of the point and then like jump to all the points that have that property? I really feel like there's something like that, but it's eluding me right now. So you have this point in the bottom left, and now you're considering the line that goes from here to here. Every other thing on this line is going to have an x mod 4 equal to 0 and a y mod 1 equal to 0. But there are points that satisfy that aren't on the line. This generates too many candidates, and I can't think of a way to skip. Like if I'm looking for if I were looking for points on this vertical line, that I could do quickly if my points were like in a data structure where I could quickly access them by their x value. So I'm just wondering if like you store y divided by x, if your points were indexed by y divided by x, or something, y minus x. Some function of the point itself, then could you quickly jump to the points that you want? Like you can in the case of vertical slope. Why couldn't you for other slopes? I think you should be able to. Okay, so if I start by thinking of, and I don't think you actually need to do this, but I think this is helping me think of it. If your point is always at 0, 0, and then you're thinking of another point on a line, then this point, the x over y of this point will be equal to the x over y of all the other points that are collinear. If x1, y1 is 0, 0, and the line is defined by x1, y1, x2, y2, all collinear points will have x3, all collinear points x3, y3 will have x3 like y3 over x3 equal to y2 over x2. Okay. So let's start over. O of n squared for each point pre-process. For each pair, jump to collinear points. Okay, so for P1 in points, I can't do my trick of skipping half the search space anymore because I want everything to be at 0, 0. So x1, y1 equals p1. And then for every point, I want to subtract p1 from it because that's the thing that's going to get my p1 to be at 0, 0. So for p2 in points, for I in len of points, points of I equals let's do P2 equals points of I. Or we'll just call it x2, y2 equals points of I. This will be equal to x2 minus x1, y2 minus y1. So that's our pre-processing. Pre-processing to put P1 at 0, 0. Okay, then we want some kind of data structure that stores the ratios of all of them. So we'll call this ratio equals dictionary for P2 in points, ratio of, and then x2 y2 equals P2, ratio of y2 over x2 equals the point, so P2. This needs to be a list, default dict list from collections import default dict, because there could be more than one point and we want to count all of them. Or you know what? We don't even care what the points are. We just care about the ratio. So this could be a set or we need to count. We just want to count how many there are here. So don't append the point, just increment the count by 1. Now, for P2 in points, or basically now we know, now we just say best equals max of like count for count in ratio.values. We don't have to generate the lines or anything. We already know this is how many collinear points there are for each line. And then we return best. So obviously, what if x2 is 0? We can just count all of those separately. So if x2 equals 0, if it's not 0, then do this, else ratio of, you know, vertical plus equals 1. What are the odds that this makes any sense? Range of this. Y2 is not defined. Yes, it is. Oh, Y1 is not defined. Yeah, because this is supposed to be x1, y1. Oh. Okay. I guess we'll have to debug this. Why don't we print ratios and P1? I mean, I am modifying the thing while I'm iterating over it, which is not a good idea. This is in the way. I can't tell what's behind that symbol. Yeah, like there's supposed to be a 0, 0 in here. Print P1 and P2. Oh, there is a 0, 0 in there. But then I'm counting one of those as vertical, which I shouldn't. I think it's just that I should, well, how do I? If P1 equals P2, what's the ratio that I put that in? I think maybe I just need to add a 1 plus here to count the ratio and skip over it. If P2 equals 0, 0, continue. Well, if it's a list of size, if it's an empty list, why doesn't this work when that happens? You're not allowed to take max of an empty sequence. I wish you could, because this is going to be uglier if I have to account for that separately. That's too bad. I guess I have to account for it separately. If ratio this is not how you do best either. Best needs to be the max of of best and this. Best collinear with P1 equals 0 if ratio I hate this. I hate what I've written here. Best equals 0. Okay, this is a stupid way of doing it. For count in ratio dot values, best equals max of best and count. That's more like it. And now everything's wrong because I forgot my 1 plus. Because you got to count your own P1. The 1 plus must go here, otherwise you're incrementing it too much. Okay. Is there a simple example? Why are we still returning? I guess I can just put the 1 plus over here. Did this say that points will be unique? Yeah, that's good. So we're saying for 1, 1, so where all of this is decremented by 1, all of them have 4 over, or have, it's not exactly a slope, but it's like a slope of 4. That's not true. It's y over x, right? So it would be 2 over 1. That's not 4. So what are you talking about? How did this... So we're grabbing the point and then we're changing it. Like, can I print points over here? X, Y. So it would be 1 over 2, 2 over 4. Why is that 4.0? That's not 4.0. Oh. I never defined x2 and y2. Oh, okay, okay. Okay, and now it's gonna work, right? It does! And now it's gonna be fast, right? It is! We don't need this line thing anymore. I guess we just have two solutions. Okay, that's awesome. Yeah, that's a really hard problem, but the solution ended up being pretty elegant. How did other people do it? Same thing? Give me some Python solutions. Slopes and hash tables. Sounds familiar. So they didn't do the pre-processing thing. Which actually I knew you wouldn't have to do it, but this is not how I thought you would not have to do it. Because, okay, so this is what we were calling M. Answer is 1. For each point, store the slopes. Find the slope here and put it in there. You know what? Yeah. This is what we're doing, but without having to do all of the modification of the points in advance. Because what I'm doing when I do this is finding the slope. I'm just doing it in a weird way. Because I end up with y1 minus y2, x1 minus x2 in this thing. So yeah, I am doing the same thing, but in a worse way. Because it involves this pre-processing that you wouldn't need here. But I guess it's not like strictly worse. There's some advantages to this also. I guess also I'm iterating over the ratios at the end, and they're just getting the max as they go, which makes sense. I wouldn't need this outer loop. I could just check it here. And then what are they doing? Oh, okay. They're just saying infinity, whereas I'm saying vertical. All right, cool. I mean, yeah, this is what we did. Okay, next problem. Number 150. Evaluate reverse Polish notation. Medium. You are given an array of strings tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression. Return an integer that represents the value of the expression. Note that the valid operators are plus, minus, times, and division. Each operand may be an integer or another expression. The division between two integers always truncates towards 0. The division between two integers always truncates towards 0. Okay. There will not be any division by 0. Okay, that's helpful. The input represents a valid arithmetic expression in reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. All right, so first of all, let's cheat because, oh, you know what? Never mind. I was going to say let's just call Python eval, which would be cheating, but I can't even do that because it's in reverse Polish notation. So reverse Polish notation means your two operands are after the operator. No, wait, it's starting with the 2. It must be the opposite of what I just said. The operator comes after the operands. So left operand, right operand plus. And then you evaluate, and this becomes an expression that is the left operand, right operand times for this. Okay, so if I read this one, let's not look at what it is to make sure we understand. No, we don't. I don't understand because I would expect an operator to have to come here. So I guess I don't understand reverse Polish notation yet. Is it just that you start on the right side? And yeah, is it just like you start on the right side and it's the thing I said where it goes operator, left operand, right operand? So operator, and then the left operand, or I guess it would be right operand, left operand. The right operand is an expression whose right operand is 5 and left is 13. So that's this. And then the left operand of the first thing, I think that's what it is. So you read from right to left and then you evaluate. Okay, there's a few ways to do this. I think you can do it with a stack probably. You can do it with recursion. Actually, I don't know how you would do it with recursion because you don't know where the end of where your second operator is going to be. You don't know how this splits into 2 operators, so I think you have to do it with a stack. So stack equals tokens. We already have tokens, so we can just use it. Let's do stack equals tokens. Stack while stack dot pop. This will always be the operator. And then the 2 operands are stack.pop and stack.pop. And then you evaluate this, and then you push that back onto the stack. No. Yes. You pop the left thing equals stack.pop. What's the word for what things are? I guess it's a token. So token equals stack.pop. If the token is an operator, so if token in multiply, divide, plus, minus, then you have a token, or you have an operator, and now I want to extract two operands out of my stack. Otherwise, I have an, I just have a value. What did they call them? Just integer? And then I can evaluate it. So operator equals none. Operand 1 equals none. Operand 2 equals none. So while there's stuff in the stack, you pop a token. I'm actually having a little bit of trouble thinking about how you're supposed to put stuff back into the stack. So you take times, and then you've got some operands in here. So you pop the next thing. And if it's an operator, then it's going to be an expression. I mean, this is why the recursive thing seems easier for me to do. I know the stack thing is going to be more efficient, but I'm trying to wrap my head around this first. So let's try recursive first. Token equals I can't modify the list that they're giving me, right? Yes, I can. Yes, I can. Because nothing else will have to consume it anymore. Okay. I think actually if I'm going to treat it like a stack, I should start from the left side. And no, because I have to start on the right because I don't know what expression those things are in. Okay, so I pop the token. If token not an operator, times, divided, plus, minus, return token. Like it's an integer, I've evaluated it, here's the value. Otherwise, operand 1 equals self.eval rpn of the remaining tokens. That's going to modify the list of the remaining tokens. And then operand 2 will be what's left. And then like if token is times return operand 1 times operand 2. It's just it's plus, you do plus. If it's minus, you do minus. If it's divided, you do divided. Just to confirm, Python 123.pop. Okay, it removes the last thing in the list, which is what I want. How is an operand not a integer? Oh, because it's always strings. Return, so cast it to an int in this case. And I think you want to cast all of these into ints. It's only the divisions that's going to give me trouble, though. Like, I shouldn't need this int. These are already ints. These are already ints. These are already ints. This is the one where I have to like be careful about the rounding. Round towards 0, they said. So if it's positive, this rounds towards 0. If it's negative, then I don't know what Python does. Python. Negative 0.1 times 2. How about just int of negative 0.1? Int of negative 0.6. That's rounding downwards, not towards 0. So if something is negative, I want to add 0.5 to it. Wait, why did that round? No, sorry, wait, I'm confused. That rounded to 0, that rounded to 0, that rounded to 0. So Python, just casting to an int already rounds towards 0. So I'm just not doing the reverse Polish notation correctly. I guess. So that I would expect this to be equal to you're doing a plus of 4 and this, which means 13 divided by 5. Is that one of the examples so we can check? Yes. Oh, I think I just have the operands order mixed up. There we go. Okay. All right, submit that. And I think there's a way to do this with a stack that would be better. So let's think about that for a second. How would you do this without recursion? Without recursion, you want to put stuff back into the stack instead of recursing. But that's kind of hard to think about how you would do that. So you take the times. Now you need to do the left and the right side. I don't know how to do that because I think you kind of need to go through the whole thing. Unless like I take the times off, I put it in my stack. I take the 3, that must be how you do it. So stack starts empty, while tokens, we're going to consume them one by one. Token equals tokens.pop. If what goes into this? Like every time we have an operator, we put it in the stack. Yeah, it's like we must remember to evaluate this. So if token in times divided plus minus stack dot append token, else if it's just a number, then you can start evaluating stuff. So I think it's like operand 1 equals none, operand 2 equals none, or operands is just a list. Okay, so else you add it to your operands, operands dot append int of token. And if operands, if we have 2 operands, then we do the operation on them. So operation equals stack.pop. Ah, okay. It's not that we're going to remember two operands. We're going to have a result that starts at 0, let's say. That's kind of weird. Let's just do operands. But we keep putting the result of each operation as the first operand. So yeah, we appended it as an operand. If we have 2, we pop the last operation off the stack and we compute it. So operands of 0, if OP equals plus, then operands is going to be equal to operands of 0 plus operands of 1. Elif minus, you do minus. Elif times, you do times. Elif division, you do division. And then at the end, you return this. I assume I'm doing them backwards again. Why would this not work? The operands list is kind of weird and it's making it hard to think about. So if result is none, then result equals int of token. Continue. Otherwise, this is if, otherwise, we don't have operands. Here, otherwise we just do result something equals, and then call this operand. We'll call it its token. Minus equal times equal divided by equal, and then return result. Okay, I'm definitely just doing the wrong order. I must just be doing the wrong order. Come on, how is both directions wrong? What am so times goes into the stack, 3 becomes our result, plus goes into the stack, 1 will get added to our result, so now our result is 4. 2 will get multiplied with our result, so now our result is 8. Wait, but it's supposed to be 9. So I've once again misunderstood what I'm supposed to be doing. Times 3. Okay, so you can't do this the way I'm doing it. I like once I get this 3, I have to remember this for later. It's not the right time to put it in our result. So what would the rule be? You take the times. So whenever you have an operator, you push that into the stack. Then when you have an integer, you push that into the stack. Unless the last thing in the stack is also an integer, then you apply it. So And then when you apply it, you push that into the stack. Okay. So you don't have operands, you just have a stack. Tokens always go into the stack. You don't have result, or I mean, operators always go into the stack. If the last thing in the stack is not an operator, times divided plus minus, then you do the operation. So left equals int of token, right equals stack.pop, and operator equals stack.pop. Let me take this out also. So here we've got left and right. Left plus right, left minus right, left times right, left over right. The result goes back into the stack. So stack.append. Here, we can just do that, and then stack.append result. The issue is we're consuming tokens. But how do we, but like, is stack necessarily going to be empty at the end of this? I think it will. I think it will. Because it's guaranteed to be a valid expression. Oh, I forgot to add because the else here is that you just stack.append int of token. I can't just do this. Like it can't just say false. Fine, I can just do is instance if it's an int, then you append it. Else you have to do this stuff. And I can unindent this and just add a continue here. Okay. Times goes into the stack. 3 goes into the stack. plus goes into the stack. 1 goes into the stack. Yeah, I guess at the end of this, we also have to... This is what I'm not understanding is... it doesn't seem like we should have to do 2 iterations. Like, am I just not iterating properly? Like, can I just take the tokens and say that's my starting stack? No, because when I pop this and then this, now I don't have an operator. What I would want to do is like go through this. Adding to a stack. Once I get to oh my God, it's so simple. Once I get to an operator, the 2 last things in the stack are consumed. That's what I want to do. Operators should never go into the stack. We start over. For token in tokens. If token in times divided plus minus, then we eval. If it's not in that, then we just add it to the stack. Stack.append int of token. Okay. So here we eval. How do we eval? We just do if token equals times. You know what? Let's do the Python trick. We'll just make a string and evaluate it. So stack.push f of op1, op, or we can call them like left operator and right. Operator is token. Left and right are stacked up. And that's literally all there is to it. Return stack of 0. How can it be empty? Oh, because you don't push, you append? I guess I don't know why that didn't fail at the push. And I forgot to eval this also. Not that that's why I'm failing. I don't understand why I'm failing. I append, then I pop 2 and I push 1. And then I append, and then I pop 2 and I push 1. How could I be empty? Print stack as we go. Print token and stack. Because I need to continue, obviously. Right and then left must be it. And we have to round also. Okay. Yeah. We have to round inside the eval, or I guess we can do it outside the eval. But I was just trying to convert a string into an int, which made no sense. All right, let me see 0 milliseconds. That's not 0 milliseconds. We got slower. Okay. Perhaps because of the eval. Whatever, I'm happy with that. That's all. Hope this was helpful. If it was, please upvote me on Leetcode or on YouTube. And that's all for now. Thank you.